recording, guys. Okay, so final exam. You will get a formula sheet. Okay, the formula sheet's right here. I'm actually gonna print this for you guys so you guys can practice using this. But so like, I mean, you guys should know the first box, but you get it. The even odd stuff like the like hey, you know, cosine negative x is cosine x or sine negative x sine x, blah blah blah. You guys should know that. The co-functions.
Remember, cosine is complement of size. As we have 5-2 instead of parentheses, like with tan 50, in reverse. Pythagorean trigonometries. If you somehow blank on like maybe the variation of it, I mean, you can always derive it like divide both sides by sine squared, divide both sides by cosine squared. You get the two variations, but
you know, I gather the first three rows, you guys should be fine, even if you didn't have them, but you'll get them. I think what will help the most will probably be the bottom ones, right?
Like some different formulas, you don't have to memorize and give it to you. In fact, I've always been this, when I taught algebra 2 daughters and gave very minimal formulas. And I always gave this one. This I wouldn't do because you always derive these from them anyway. So you have all this. And the power reduced ones are key too. So this is going to help for like verifying trigonometry or solving trig equations that might look kind of weird.
Don't have this as reference here. So you get all that. And there's more. You get all the conics. Okay, you get all that. And actually, I do need to add a bit more to this because I should also tell you that like c squared equals a squared minus b squared, c squared equals a squared plus b squared for like the foci for ellipses and hyperbolas. For ellipses, it would be c squared equals a squared minus b squared because c is going to be shorter, right? But c is longer. For hyperbolas would be, but I'll give that to you anyway. Don't worry. For the foci stuff. The symmetry of polar curves, I gave that to you guys obviously on the last test, so you guys get it here as well. The trig form of a complex number, I am going to put the Mott's theorem on here too. I don't know why it's not on here. I'll put up more things. So I still need to update this. So maybe while you guys are working, I'll make some updates and print it. Because you guys do need a little bit more than just this. This is not quite enough. But I will put all the stuff that we did in the last topic we covered on Wednesday last week, I believe, on the Mott's theorem and the roots. So that's pretty much what to expect formula-wise. Now, the test is going to be given in two parts. There is a part one, there's a part two. I do have to do a non-calc because you got to know your unit circle. You got to be able to do without a calc. You got to know how to graph some trick stuff without a calculator. So it will be significantly shorter than part two. Part two will be calculator allowed. Okay, now this is the part you guys are really interested in knowing what's on the final. So let's do that right now. So let me share a whiteboard. Here we go. And let's talk about some of the finer details. All right. And what I'm willing to disclose. All right. Okay. And I will save this as a PDF as well. So I'll do a screenshot. So if you want to write down, go. If sometimes it's good to write things down, you know, it doesn't hurt. But you know, if you just want to kind of sit back and relax and hear me talk, that's great too. Okay, part one, part two. Okay, part one is non-calc. Part two is calc. And I will pardon my language, you're pretty much shit out of luck if you don't have your calculator. You do need a calculator for part two. It's gonna be really tough if you don't have one. We do have a bucket of calculators, but to be honest, like none of the batteries work. I keep telling myself I'm gonna bring batteries to my house or buy it to the store. I just don't have time, so I probably won't have time this week. So really make sure you have a calculator, fresh batteries, or make sure it's fully charged. Because there'll be a problem if you don't. And just, you know, the final exam will be in courtroom room, which is downstairs. I think it's like CAM 154/156. And it'll be at 12:30 to 4:30 p.m. Well, if you have extended time, seriously, I had one student last year. She was all 4 hours. Oh my God, it was crazy. But anyway, it's a blessing and a curse, they say, right? But anyway, but if you have extended time, you'll get it. Don't worry, you'll have your extended time. But I prefer to try to arrive by 12:15. So you're not feeling rushed. So just keep that in mind. In terms of point values, there'll be 30 points here and 70 points here. So it comes out nice and neat, 100 points. Number of questions. Looks like we got ourselves 5 questions here. And here it looks like we got ourselves 6 questions, but they have several parts. Looks like, yeah. So what I probably suggest in terms of the point values, in terms of the effort you have to expend, probably part 1 in terms of pacing. I would suggest part 1 should take somewhere between 30 to 40 minutes. And part 2 should take about maybe 60 to 80 minutes. The final exam is designed to last about 90 minutes. So it's 11 questions, a little bit longer than a normal test. Normal test about 8 questions, right? They're designed for a whole hour. So yeah, a little longer. I have not worked it out yet. My rule is a times 6 rule. So however long it takes me times 6, how long it should take you guys. But I might have to recalibrate because you guys are a really bright group of kids. And you guys are strong students, so maybe I'll do a times 4 rule. We'll see. I'm gonna work out this afternoon and let you guys know on Thursday. Times 5, we'll compromise. But if it takes me more than 20 minutes, and I do need to trim the file, I will trim it. If I trim, I'll let you guys know. Because to be fair, I don't want you guys. I don't want the last thing I want is like, people. Well, I don't want them crying, but no crying, please. But I don't want I don't want you guys feeling stressed. Like, oh my god, like I have like 3 more questions, like 10 minutes left. So I really try to make sure it's appropriately timed. So I mean I work fast. I've now seen the questions. So we'll see how long it takes me, and I'll trim it. But that's the plan, to be able to do it about 90 minutes, and then you have a 30-minute buffer in case you want to go back and check your work, or say you get stuck on one problem and you need to go back and look at it. You have that buffer. However, when you turn part 1, you cannot go back to it. Just so you know, once you turn part 1, you kind of reach a point of no return, and now you're just on part 2. Because then you have a calculator, you can't go back. And the proctor is gonna be really strict about it, because I can't, I'm not gonna be proctoring the whole time. I mean, I'll be in the room, but there's another proctor in the room too. So they have very strict instructions that once you turn part 1, you cannot go back to it. That train's left the station. So yeah, keep that in mind. But of course, you can go back and double check your work within the section, whichever section you're on. Okay, so now let's talk about some of the finer details. Here we go. Any questions so far about what I've said about all this? That's kind of general overview. No. Okay. All right. Cool. And again, you will get a formula sheet. So actually, formula sheet provided. Okay. Let me save that again. Here we go. Okay. That's clear. All right. Part 1. What to expect. Definitely expect, evaluate a trig function or inverse trig function. So basically unit circle. If you guys want a blank unit circle, I'll provide that also. I mean, I'm not going to give you a filled out one, but if you want a blank one, just start filling out when the test starts. Audie, go ahead.
So by that you mean like simplify or
Yeah, totally. Yeah, right. Yeah, let me give you an example. Say like find me the sine of inverse cotan. Let me make sure this works. Let's say I had something like that, right? So that means actually inverse tan of undefined, right? You got to flip that. Well, where's tan undefined? That would be undefined on 5 and 2. So I want sine of pi 2, which of course is 0. Sorry, 1. I should know that. So something like that you could see, like that kind of problem. Number 2. More trig. But non-unit circle. So we'll give you a good example. So you're given cosine of A is like I don't know, like -3/4. and you're in Q2, find like I don't know, cosecant of 2a. Something like that. So what would that mean?
That means that you need to draw a triangle with like quadrants, you need variable sides, deterministic sides, and then use an identity, right? Well, we know sine 2a is sine 2 theta, sorry, sine theta cos theta, that's one over that because it's cosecant. Actually, I'll look it up. If I were to work that out,
It would look like this, right? How do I label the sides, guys? How would I label the sides here? Where's negative? Where does -3 go? Where's 4 go? And what would this be? No, no. Duke, root 7. Root 7. No, I tricked you with that. That's my fault. I tricked you. So root 7, right? Okay, then this is going to be 1 over sine A cos A, right? Sorry, I take it back. 2 sine A cos A. My apologies, right? Because remember, sine 2a was 2 sine theta cos A, so it's 1 over. Well, sine A obviously is going to be root 7 over 4, right? So 1 over 2 times root 7 over 4. And cosine A, of course, is -3/4. So you get -3 root 7. Oops, sorry. You get 1 over -3 root 7 over 8. Is that correct? And then you flip it over, and then you have the answer. I won't ask you to rationalize denominator, so you don't have to rationalize if you don't want to. I won't ask that. It's up to you if you want to. Yeah, do I? Actually, yes, you may leave simple radicals in denominator. That's fine. Yeah, the instruction says so. So, okay. So that's how the first couple of questions will look like that. Okay. So no surprises. More in part 2. Oh, shoot. Let me save that. Here we go. Okay. More in part 2. Definitely. Sorry, part 1. Geez. More in part 1. Convert polar coordinates to rectangular and vice versa. Convert polar equation. So this is coordinates. This is equation to rectangular and vice versa. I'm not going to tell you which one it will be. Like, well, I'll give you a polar equation, got to make a rectangular, or I'll give you a rectangular equation, got to turn polar. You'll find out on Friday. But yes, something like that. And then writing the equation of a trig function when given the graph. I won't tell you which one. It could be tangent, it could be cotangent, it could be cosine, secant, it could be sine, cosine. I won't tell you. What this means, just so you don't waste your time, I'm not going to ask you to graph the trig function from scratch. So you won't have to graph trig because you guys have enough practice that. So don't have to. I mean, it's good practice to do to help you with number 5, because if you know how to graph trig from scratch, you should be able to do 5 just fine. But I'm not going to ask like directly like graph me y equals -2 cosecant of 2x minus 1 inside the parentheses plus 2 on the outside. I'm not going to do that stuff. Because you guys done enough of that practice last year. So yeah, Carl, go ahead.
Can you specify whether it's a
Oh yeah, of course, yeah, totally, yeah, because actually I might do both. So you'll find out. So but yeah, I will so those are the 5, no surprises, right? Those are the 5 questions I'm asking. Okay. All right. So I don't want to do this PNG PDF. There we go. Okay. Let's keep on trucking here. Then for part 2, here's what we're gonna do. Part 2. Number 1. I'm gonna ask you to state, improve symmetry, of a polar curve. Both graph and equation will be provided. I mean, the equation obviously you want to have because you got to test it, but the graph is nice too, so you can visualize it, right? So that will be provided. So that's pretty easy. That's not gonna be hard. I think I'll be fine. Write the equation of a conic section when given information about it. I'm not gonna tell you which one though. It could be parabola, circle, hyperbola, or ellipse. You'll find out. Not that complicated. That was a complicated one. Write the equation when given information, given info about it. Not as bad as a tough one. On the conics test. Yeah, remember that one where I was very cryptic about it? I'm not that cryptic. It's pretty more explicit. Like, hey, here are the vertices, here are the co-vertices. It's gonna be a little more, a little easier to figure out. Also, convert to parametric form. We already done enough converting a polar from rectangular, so I'm not going to repeat the efforts because that will be taken care of in part one. But I'll ask you to convert this to parametric form as well. So again, I won't tell you which conic section, but that's the conic way I'm going to test the conic. Okay, questions so far? Nope. Okay. Let's see. Trig stuff. Part two. Verify trig identity. I've given you guys a lot of practice, especially on Friday, the extra packet I gave you guys. And James, I need to give you a packet also. Yeah, it'll be a good one. It won't be too crazy. It won't be this way. Won't be multiple angle. So not as bad, which you guys did fine on the test. As the so like you might have an identity where like sine 3 theta plus blah 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 equals a bunch of junk, and then you have to change sine 3. You might remember the word.
Yeah, the last one.
Yeah, like actually, let's pull it up right now.
One of these, mess it up.
Yeah, not like that one, guys. Not doing that one. Not doing that one. But and probably not that one either. But 6 is too easy. So somewhere kind of a little more like 6, but a little more challenging than 6. But nothing with a multiple angle. Yeah, that was the and but like something like number 2 in the non-calc, like where I give you some, it's like not unicircle stuff, like hey, it's which quadrant, I give some information, and you got to like tell me like the exact value, like something like that you'll see. So for sure, right? Anyway, let's go back to Zoom. The fourth question. Find roots of a complex number or De Moivre's theorem. Remember, De Moivre's theorem is when you're like actually expanding and multiplying. I'm not gonna tell you which one it is, but it's gonna be something like that. So basically, from our last lesson.
But those formulas will be on the thing.
Yep. Okay. Formula will be provided. Something with vectors. Totally, word problem. You read you're a mind reader. Vector word problem. Most likely. Actually, what the heck? Merry Christmas, guys. Airplane. Wow, look at you. Did you see the final? Just kidding. No, I'm just kidding.
So just to clarify, Mr. Reed, there's no bearing on this.
I'll put bearing on yours, but everyone else no. Yeah, no, right. No bearings. Okay. So what I will say is like, you're going like at 300 miles an hour at a direction 120 degrees. So go 120 degrees from the positive x-axis, rotate counterclockwise and go that way, right? Or say you're going 240 degrees, so you can rotate 240 and go that way, right? So yeah, that won't be that bad. It'll be pretty easy. But see, some of these problems are gonna have like the verified identities can take a while. The vector word problem might have like multiple parts. Again, the last one, I'm gonna call this the Duke Tom special. You see why? No, it's just a joke. So you're gonna again, I'll just say right now. Yes, find points of intersection. For two polar curves. So basically, actual versus physical, or Duke's case, the virtual. Intersection, sorry. Points of intersection. Yeah, actual is like what you get algebraically, and then physical like what you see on the graph. Actually, sorry, that I didn't mean to say. Gotta be careful with my words. It's really just actual. I don't know why I wrote physical. I think I was just trying to give Duke a hard time. Yeah, so that's the final, guys. So your studying should be very focused because these are things we had on the test. So there's just really no surprises. I mean, it's encompassing 4 months, 3-4 months of material. Now, one thing I could do for you guys is kind of point to problems on the repacks that me so far that are like this. So I can kind of highlight certain problems that are important to look at. So let's go through the review guides really quickly. Or sorry, the review problems. And then after that, I'll give you guys another packet and you guys just get to work. Okay. So let's see here. Let's go to chapter 4 and 5 problems first. Oh, that's
Yeah, that's not great.
What are we doing? I'm projected.
You're projected. No, you're not. I can't see the
projected.
No, you can. You can. Is it out? Is it out now?
If you just go to the night.
Okay. It's not out. It looks like to me.
It was out last night.
Okay, so I click here.
All right, guys, really quick, only about government, guys, get to work.
Yeah, I'm projected 121 today.
All right.
So is there any?
All right, going through this here. I would say, let me go to Zoom again. Still recording. Share it full screen. I would say, I mean, you should know 44, but that's a little too easy. I mean, definitely know 44 well. Just as the chapter 4 and /5, the trig stuff. I mean, definitely know this one because I mean, but it's going to be baked into like a bigger problem. Like, hey, find me the inverse tan.
Of sine of 13, 5 or 6, something like that. What's that, sorry? I'm in there.
Before, but make sure you know 44 well. Definitely know 45, 46 well. Because that's non-unit circle stuff, right? You know, these are non-unit circle, right? So definitely know that. Totally, right? 44, there you go. I mean, 47, you should know those graphs. I'm not going to really ask that. Because I'm just going to give you a graph. I mean, you should know how to make these graphs. You should know 47 also. But more specifically, I'm going to give you a graph and write the equation from it. But if you could do 47, you'll be fine for the final. Definitely 48 for sure. Inverse trig. Definitely 48 for sure. Don't waste your time with these here. Don't waste your time with those. I'm not going to ask you solving trig equations. If you got there, fine. If you haven't, just cross. Don't worry about it. But if anything, if you haven't really done much of this, 44 through 48 are good ones to do. We've not done science, so I really wish we did. I really love these problems, but it's not on there. Don't worry about 52 and 52. Don't waste time with it. You should know how to simplify. I mean, you should know your identities. So I mean, you should know this. But we're not going to solve trig equations. So you can cross off all 54. If you got to, that's okay. You got good practice. Definitely, you're going to want to know how to write some of these because I could ask you to use some of these identities to evaluate these things. So definitely these are good. And this is very good because I'm going to ask you to do trig identities. But other trig identities you should focus on, I think the first 5 are good. I would also say these. Oh goodness. Yeah, right. These are good. Cross off Q and cross off R. Because those have multiple angles, right? What's V about? Oh, those are an issue. Okay. Yeah, I guess apparently V didn't make sense. T and U also out. But these are pretty good ones as well. So, okay. So if you haven't got through all this, this is what you could focus on. Or if you just want to like look at those again, that's fine. And then for the other packet, this right here, and I put the answers in school. All right, did I give you guys the answers? From school. Okay, great. All right. Let's see here. Vector stuff. No bearings, so I'm gonna get rid of that one. Get rid of that one. I mean, shouldn't I do 3? You know, I might let me make some more problems for you guys because I am gonna ask like 1 and 2. Just I'll give you So let me take it back. I do like these, but I'll give you in standard position. That's how I'll do it, you know. So likewise here, standard position. I do good.
But we found ours gonna be like degrees, so radians.
Right, they'll be in degrees. Yeah, because that's how they do in real life when they fly. They don't do radians, otherwise planes will crash. Yeah. I mean, 3 is kind of good. We haven't done like direction south of what east. So again, I mean, it's not hard. It's just like if you're going south of east, like okay. So you know, here's like never east really. So yeah, here's east. You're going south that way. But I'll give you the direction anyway. So it'll be standard position. Won't be like that. 5's too easy. 6 is too easy. Definitely 7. I did talk about converting. You should know 8. Should know 9. Definitely these 2 for sure. Not gonna be asking that. Not gonna be asking that or that. You go ahead.
So for number 8, do you want to give standard rules?
I think you just be aware of it when you're like solving like where they intersect, and just being mindful of
So it'd just be 8 of you -8.
Yeah, exactly. Yeah, I mean, yes, there are variations. You can go around many times. Let me just cross it off. So now I'm confusing you guys. Just cross it off. I mean, you should be aware of that, but I'm not gonna ask that question directly. Yeah, I'm not really gonna be asking 15 or 16 or 17. 18 you should know how to do, as well as 19, as well as 20. You should know how to do, but 21's a big one. That's a big one. 18, 19, 20 just helps you understand how to do 21. Yeah, so again, 21, that's a very good one. Actually, both these are very good ones. Actually, these as well. But we never done sequences. I do gotta figure out what we're gonna do in the spring, so I'm not 100% sure. And yeah, and not 31, 34 either. We're gonna do those. So hopefully this makes your studying a little more efficient. Okay.
And then one last thing, you guys can work. No, just more you guys here. Here is more Fox Fox. Answers are included as well. Let me tell you what probably gonna. I think it's the right side of it.
Monday, I was just like. Friday we have a Sunday we have a second period.
All right, one last thing, guys. So one last thing here, guys, and I'll close the video. All right. Definitely that's a good one. That's a very good one too. We've not done law, sine, law, cosines. We're not doing angles of elevation or depression. So cross off 27 to 20, but 25, 26, 30. Those are good ones to try those today. Cross off 31. We're not gonna do solutions. 32, we're not gonna do a word problem with trig, but it's a good problem just to be able to identify these things, you know. Definitely 33 is a very good one. That's a very good one. 34 is also very good. And you got plenty of identity practice to do there. All of them are good. A, probably you could cross off A because I'm not doing double angle there, but yeah. 35, cross off. Yeah, 36, a little too easy, but 36 is good. 37 is too easy, but it's still good to do. 38. I think we'll ask you guys to do. I mean, I'm not gonna ask you to sketch by hand, but maybe what I can ask you to do for 38 is try proving the symmetry. If you want to do that. So you get some practice there. So you guys got plenty. We still got another. We'll go to what, 9:50 today? 9:40. Yeah, so you got plenty of time to practice. So have at it. Let me actually revise the formula sheet and hand it out to you guys. I'll print it and hand it out to you guys so you guys have access to that. And if I find some more practice problems, I'll produce that as well. Okay. So I want you guys to do some practice. Okay. Ask questions. Yeah.
I don't realize what my teaching was like.
Good.
Ask the next experience.